This lesson, entitled The Bonding Continuum, is going to help you to understand the differences between the types of bonds that can exist between atoms, and it's also going to help you to determine how you can actually identify what type of bond will exist between the two atoms. You'll remember from our previous science courses, and as well in the review, we talked about a bond, and we discussed the fact that it's a force that's holding atoms together. The types of bonds that you've learned about so far are ionic bonds and covalent bonds. And these are the extremes of our continuum. So let's just talk about what a continuum is for a moment. Something like the continuous spectrum. That's an example of a continuum of the rainbow. The colors flow from one to the next. So our bonding continuum is going to have the types of bonds flow from one to the next. So what I'm going to recommend that you do is put your page horizontal. Okay, so you've got lots of space. You're going to make a line go all the way across your page. This is our continuum. This is one extreme of the continuum where we're going to put some information about ionic bonding. This is the other extreme of bonding, which is the covalent bonding. And then we're going to discuss a new type of bond for everyone in the middle. Okay. What we're going to put above and below the line, we're going to put the title above the line. We're going to put a little bit of an explanation and an example here, just to give you an idea of what to expect in terms of giving yourself space to make this note. Okay, so first of all, let's record the extremes that we have. So the ionic bond is type 1, and it's one extreme. Okay, and then at the other extreme, we've got the covalent bond. Okay, now I'm intentionally leaving space below the titles here. Okay, we'll fill that in later. Now in our review, it's very clear that people knew that an ionic bond is formed usually between a metal and a nonmetal. Now, as you know, all bonds are being formed because atoms are trying to achieve stability. So in an ionic bond, when we've got a metal and a nonmetal, the atoms achieve stability by transferring electrons. So there's a transfer of electrons from the metal to the nonmetal. And what we are left with when that happens is a cation and an anion. So let's look at an example here. If we've got something like sodium chloride. Okay, sodium has 1 valence electron and chlorine has 7. Sodium, our metal here, has 1 electron to lose in order to become stable, while chlorine has 1 electron to gain. So if the sodium transfers its electron to the chlorine, each of them will be stable. Now what we'll be left with is a sodium cation, because it has lost an electron, and a chlorine anion, because the chlorine has gained an electron. Now it's very important to understand that this part here, the transferring of electrons, is not actually the bond. The bond exists between the cation and the anion. Okay, so the actual bond is the force holding these two ions together. And in this case, the reason they're attracted to one another is because we've got a full positive and a full negative charge. The other extreme of bonding, or holding atoms together in order to achieve stability, is the covalent bond. And a covalent bond usually occurs between between two nonmetals. Now you'll notice that I'm using the word usually. In grade 10, you would have just said occurs between two nonmetals, or occurs between a metal and a nonmetal for the ionic bond. Okay, you're going to see why this continuum is forcing us to leave room for some exceptions to our bonding definitions. Now in a covalent bond, the atoms will achieve stability by sharing electrons. So let's look at an example here. If I've got a chlorine atom with its 7 valence electrons, okay, and another chlorine atom with 7 valence electrons, each of them want one more electron in order to be stable. If one gave the electron to the other one, then it would still not be stable. So rather than transferring electrons here, if the atoms are able to share the electrons and form a covalent bond, okay, they're both going to be stable. Now, this example here has the bond occurring between two atoms of the same type. That's not always the case though. And we've got lots of cases where we've got two different types of atoms that are bonding. So you could have something like Cl bonding with Br, for example. Okay. Now, as we talked about, these are the extremes. So ionic bonding is where we've got a full transfer of electrons, which is one extreme in the bonding continuum. Covalent bond is where we've got pure sharing of electrons, which is the other extreme. So what we have in the middle here is what is called a polar covalent bond. And in a polar covalent bond, what we have is that the electrons are being shared, so it's still considered covalent. Okay, but rather than them being shared equally, they're being shared unevenly. Okay. Now what this is going to do is it's going to cause the actual molecule to have a slightly positive and a slightly negative end. What I'm going to do is use an example, and I'm going to show you afterwards how you actually decide which type of bond you're going to have. Okay, so for this example, we're going to work with carbon and oxygen. This is a classic polar covalent bond. The electrons here are not going to be shared equally. What's going to happen is that oxygen is going to have a stronger attraction for the electrons. So the electrons are actually going to spend more time closer to the oxygen atom. That's going to leave the oxygen slightly negative and the carbon slightly positive. There are two ways that we can show that. Okay, I can put a slightly positive and a slightly negative symbol. Okay, this is a little delta. So it's like an S with a little curl on it. Another way that we can identify a polar bond is with a dipole. And a dipole is an arrow. The arrow points in the direction of the electrons. So in this case, the electrons are spending more time closer to the oxygen, leaving the oxygen slightly negative. The other way that you can remember which way to draw the dipole is that the tail looks like a little plus sign, so it's on the side that is slightly positive. So this guy here is called a dipole. Now, the different types of bonds occur because atoms have a different attraction for electrons. Okay, so you'll remember from the previous unit, we talked about the property of atoms called the electronegativity. Okay, the electronegativities you'll find on page 71 in your textbook. So I would recommend that you pause the video and get your textbook out so that you can follow along. Now, what you'll remember from our study of electronegativity is that electronegativity is the attraction that an atom has for electrons. And it's a relative number. So an atom that has a large attraction for the electrons will have a high electronegativity. Recall that fluorine has the highest in the table. And something that has a low attraction for